Unless you've been living under a rock, you've probably noticed something extraordinary happening. Artificial intelligence isn't just reshaping our apps, jobs, or social media, it's quietly rewriting the way we understand reality itself. From your phone's search bar to billion-dollar research labs, AI is everywhere. It answers our questions, writes our code, paints our art, and now, it's doing something far more ambitious. It's starting to do science. But here's the real question. Can an AI, not a human, actually discover the secrets of the universe? Can a machine become a scientist? And if it can, do we even understand how it thinks? Welcome to a new chapter in human discovery, where telescopes see beyond galaxies, guided by code instead of curiosity. This is how AI is revolutionizing physics and astronomy, and maybe even redefining what it means to know something. Let's begin with a story. In 2023, the European Space Agency launched one of the most ambitious telescopes ever built, Euclid. Its mission? To map dark matter and dark energy, the invisible forces that make up 95% of our universe. While scanning billions of stars, a scientist named Bruno Altieri noticed something unusual, a faint, perfect ring of light around a galaxy called NGC 6505. It wasn't just a pretty picture, it was a cosmic miracle. Altieri had found what's known as an Einstein ring, a rare illusion caused by gravitational lensing. When a massive galaxy bends the light of another one behind it, the two align perfectly, and the universe paints a glowing ring of distorted light. It's nature's own magnifying glass, allowing us to measure hidden mass, invisible matter, and sometimes, even glimpse galaxies that existed billions of years ago. But here's the twist. Finding one Einstein ring by chance is lucky. Finding thousands is impossible for humans alone. Why? Because Euclid's data isn't measured in gigabytes, or even terabytes, it's measured in petabytes. That's hundreds of trillions of bytes. Enough data to drown every computer on Earth. Hidden inside that data are cosmic secrets, thousands of gravitational lenses, galaxy clusters, maybe even the fingerprints of dark matter itself. But no human could ever sift through that much information in a lifetime. So scientists turned to their new research assistant, AI. Robot face AI, the good. AI, and especially machine learning, has become the most powerful lens humanity has ever built. When trained properly, these systems can recognize weak and strong gravitational lensing in massive sky surveys, patterns that even expert astronomers might miss. In Chile, AI helped scientists identify 56 new gravitational lens candidates in images from the Very Large Telescope. In Japan, 10,000 volunteers combed through telescope data, tagging 20,000 galaxies by hand. Then an AI, trained on their work, discovered 410,000 more galaxies, with 98% accuracy. That's the power of AI. It learns, scales, and never gets tired. It can search through petabytes of cosmic data in hours, revealing new structures and galaxies that were invisible to human eyes. But that's just the beginning. At Caltech, scientists used an AI called Urania to improve the world's most sensitive gravitational wave detector, LIGO. LIGO measures the ripples in spacetime caused by colliding black holes, changes smaller than 1/10,000th the width of a proton. Its precision is beyond imagination. Yet even then, AI made it better. When scientists gave Urania the freedom to design new optical systems for LIGO, it produced strange, alien-looking blueprints, designs that no human engineer would ever create. At first, they looked like nonsense. But when tested, these bizarre ideas worked. They could have improved LIGO's sensitivity by up to 15%. Only later did physicists realize that Urania had independently rediscovered a theoretical quantum principle proposed by Russian scientists decades earlier, one that had never been applied in real experiments. The AI had revived lost human knowledge, optimized it, and pushed it forward. And this is happening everywhere. AI isn't just analyzing experiments, it's starting to invent them. It's brainstorming new hypotheses, improving research papers, translating discoveries, and making complex science readable for the world. In fact, a recent Nature study showed that over 8% of all scientific papers now mention AI in their titles, quadruple the number from a decade ago. And that number is climbing fast. Scientists say AI saves them time, money, and even helps them generate brand new ideas that no human had before. It's no exaggeration to say that artificial intelligence might be the greatest scientific partner humanity has ever had. Warning: AI, the bad. But there's a catch. Because for every discovery AI helps make, there's a growing question. Can we trust it? When Urania designed that LIGO upgrade, scientists didn't understand why it worked. It took months to decode its reasoning. That's the first danger: AI often gives us answers without explanations. And science isn't just about answers, it's about understanding. What happens when AI finds something, but we don't know why it's true? What happens when our smartest systems make discoveries that even we can't explain? The Royal Society in the UK recently warned that AI could contaminate scientific data, sometimes even fabricating results that look correct. Worse still, many machine learning experiments are now impossible to reproduce, a fundamental violation of scientific method. If no one can repeat the results, can we still call it science? Nearly 70% of scientists worry AI could spread misinformation or bias. Others fear plagiarism, data corruption, or subtle discrimination creeping into research results. Because AI learns from us, and we're imperfect. If the data we feed it is biased, the conclusions it draws will be too. Bad data in, bad science out. And the irony? The very tool meant to reveal truth might someday become the greatest source of confusion. So where does this leave us? AI can see what we can't. It can calculate faster, deeper, and more broadly than any human mind. It can find galaxies hidden behind galaxies, detect dark matter through invisible ripples, and rediscover theories lost to time. But it can't feel awe. It doesn't dream, or wonder, or doubt. And that's what makes human curiosity irreplaceable. As Euclid's AI continues scanning the heavens, it may map the dark side of the universe by 2026. It might even answer one of the biggest questions in existence. What is the universe really made of? But until AI can tell the difference between what's real and what's illusion, until it can explain why its discoveries matter, we'll still need humans to guide it, question it, and keep the story of science honest. Because the universe doesn't just need intelligence, it needs imagination.